Determine if the line 4x minus 3y equals 31 is a tangent to the circle x squared plus y squared minus 6x minus 4y minus 12 is equal to 0. So it's important to note that a tangent is a line that touches a circle in one place only. So what we have to do is see, is there only one point of intersection? Is there 2 points of intersection, or is there no points of intersection? If there's one point of intersection, then the line is a tangent. Now, another way to work this out is to use the perpendicular distance method. So we take the line, 4x minus 3y minus 31 is equal to 0. So all I've done here is brought that 31 over the equal sign and became minus 31. So we then have a look at our circle, and we're going to use the formula x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So we're going to take the coefficient of x in our circle, which is minus 6, and the coefficient of x in our formula, which is 2g. So if 2g is equal to minus 6, then g is going to be equal to minus 6 divided by 2, which is minus 3. Now we know that in order to get the centre, we take that g and we change the sign. So minus 3 becomes positive 3. So the circle has a centre of 3 something. So the x value is 3. So next we take the coefficient of y in the circle, which is minus 4. And we let that equal to the coefficient of y in the formula, which is 2f. So if minus 4 is equal to 2f, then f is equal to minus 4 divided by 2, which is minus 2. So we know that the f value, we need to change the sign in order to get the centre. So minus 2 becomes positive 2. So the circle has a centre 3, 2. Next we take our formula for the radius, the square root of g squared plus f squared minus c. So we square the g, we square the f, and then we change the sign of the constant at the end. The constant at the end is minus 12. So 3 squared is going to be 9, 2 squared is going to be 4, and minus 12 becomes positive 12. So we get the square root of 9 plus 4 plus 12, which is the square root of 25, which is 5. So now we have the centre of the circle, and we also have the radius of the circle, which is 5. So next we're going to get the perpendicular distance from the centre point, which is 3, 2, to the line given in the question, which is 4x minus 3y minus 31 is equal to 0. So remember, we took the 31 over the equal sign and became minus 31. So we label our centre point as x1, y1, and we label our line as a, b, and c. Next we substitute into the formula, which is the modulus a times x1 plus b times y1 plus c, all divided by the square root of a squared plus b squared. So we end up with the modulus of 4 times 3 minus 3 times 2 minus 31, all divided by the square root of 4 squared plus minus 3 squared. And that gives us 25 divided by 5, which is 5. So as the perpendicular distance, which is 5, is equal to the radius, which is also 5, we know that the line is a tangent. So this is another way of determining if a line is a tangent to a circle. So although we could have rearranged the line to get either the x or the y on its own and substituted it into the circle, and we would have come up with one point of contact, which would have meant that the line was a tangent, that's a much longer method, and it's easy to make mistakes, especially with a line like this, where you have a number in front of the x or a number in front of the y. So if there is a coefficient in front of the x or the y, when you rearrange, you're going to end up with a fraction, and then substituting a fraction into the circle, you can lead to a lot of problems, and it's easy to make a mistake. So this is a much quicker method.